Section 5.2, the antiderivative of 1 over x dx. Well, we just learned that if you take the derivative of natural log of x, it should give you 1 over x. And so, naturally, if we take the antiderivative or integrate 1 over x, we're going to get natural log of x. Now we have to put absolute values around it because we can't have negative numbers inside the natural log of x. That is outside of our domain, so we have to put the absolute values around it. A better way to look at this, though, is actually the following. The integral of not 1 over x, but with some function on the bottom, where the derivative of the function is on top, du. That's because we can rewrite this as 1 over u times u prime times du, which is really just saying the derivative of whatever's on the bottom, right here, multiplied by du, that's just the chain rule going on. So to undo it, we'd have to make u whatever's on the bottom right there. And that would equal the natural log of u, absolute value of it, because we can't have negative numbers, plus c. So let's see about the first one here. Well, I've got 1 over 2x plus 7. Now, since there's not something just nice and pretty on the bottom here, it's not just 1 over x, I'm going to have to treat it as a u. U is equal to 2x plus 7. So du is going to be, the derivative of this, just going to be 2 dx, or 1/2 du is equal to dx. Alright, so plugging that in here, we're going to get 1/2 of 1 over u, use that right there, du, which gives us the natural log of u plus cookies, got half of it right there. And what I'm actually going to do here is I'm going to back substitute and plug in the 2x plus 7 there, and 1/2 right here using properties of logarithms, I can rewrite this as 2x plus 7 the square root, if I put that back up there, plus c. Now, you can write it like this, or you could still write it 1/2 of the natural log of 2x plus 7. Either of these are acceptable. Please recognize it in both forms. Moving on to our next problem here, same sort of thing. Well, let's see here. Intuitively, we know that the u is probably going to be what's on the bottom here, because it's probably going to get rid of what's on top. Well, let's see. Let's try that first. 5x squared plus 6x du is going to be 10x plus 6. Well, that's not what's on top, but what I can actually do is I can divide both sides by 2, once again get 1/2 du is equal to half of all this, 5x plus 3 dx. And that right there is what's on top. That's the u prime du. So this is going to become 1/2 of 1 over u du. So that's going to yield 1/2 of the natural log of u plus cookies is equal to the natural log of 5x squared plus 6x. I'm going to bring this up here, square root of that, plus c. There we go. Next example. The antiderivative of secant squared of x divided by tangent of x dx. Well, u could do it, because if u is the tangent of x, du is going to be, the derivative is going to be, the tangent is secant squared of x dx. Oh, hey, look at that right there. So this is going to give me 1 over u du, which is the natural log of the tangent of x plus c. And if we want to, let's do this for fun, natural log of sine of x over cosine of x, which I could rewrite as natural log of sine of x minus the natural log of cosine of x plus c. All these answers are valid. That's really just for fun, though. Once again, we see the derivative of the bottom is what's on top and the dx. And we see that that's the chain rule going on here, which is why this form right here is a little bit better here. We see the derivative of the bottom is on top, to go along with the du. Next problem here off to the side. Well, u is going to be x plus 1. And you may say, why are you making u x plus 1, Mr. Kuhne? Well, I'll show you why. Du is equal to just dx. So this becomes integral of 2x over u squared du. Well, what do we do about that x, Mr. Kuhne? Well, we're just going to go back here and change this into u minus 1 is equal to x. So that this becomes 2 times u minus 1 over u squared du. And so we're going to get, well, let's kick the 2 out front here, shall we? U minus 1 over u squared du. If I separate this, I'm going to get u over u squared minus 1 over u squared du. Hey, guess what this is? 1 over u. And then this is just u to the negative 2. Not too bad, huh? Because 1 over u is going to be the natural log of u, which we said was x plus 1. And since this is u to the negative 2, I can just use the power rule on this one. So I'm going to add 1 to it. I'm going to get minus, and if we bring down the negative 1, that's going to make it positive. U to the negative 1, but instead of u to the negative 1, I'm going to write it x plus 1 all to the negative 1 plus cookies, of course. There we go. So sometimes you may be saying, hey, how do I get rid of that x on top, Mr. Kuhne, when the derivative of the bottom didn't get rid of it on top? And this just goes to show you, if you take you can go ahead and solve for x and then plug it back into the top, and that can kind of circumvent the situation. The next one, we run into something similar. The derivative of the bottom is going to be 2x, but we don't see that on top. Crap. Well, we're going to do something that we haven't done probably in about a year. We're going to do long division. Divided by x squared plus 1. If I do that, I'm going to multiply it by 1. Left over with an x. So this is the same thing as 1 plus x over x squared plus 1. And now I'm going to break this into parts here. What's the antiderivative of 1 dx? Plus what is the antiderivative of x over x squared plus 1 dx? Well, this one's pretty simple right here. This is just going to be x. Right here, though, we're going to have to use some u substitution. So u is equal to x squared plus 1. So du is equal to 2x dx, or 1/2 of du is equal to dx. Move this down a little bit. So this is really 1/2 of 1 over u du. We got 1 dx right here. These are different. So this is going to give me x plus the natural log of u plus c. Once I back substitute in the x squared plus 1, and pull this up here so it's a square root plus c. There we go. So there's 2 algebraic methods you can use to get rid of the extra stuff on top if you need to. If it's the same degree or if this is higher, go ahead and do long division to subtract that to get rid of those extra terms on top. If there's an x up here, you're like, well, u's got to be the bottom, but I got an extra x up here, no problem. Just solve for x, plug the u's back in, and you can work it from there. Thanks for watching.